All right, so last time we left off on counting on our fingers, right?
Yeah.
And there seemed to be some confusion when I added 4 plus 7, and I think that Katie's suggestion was a good one, so I'm going to give you a suggestion from Katie on how you could also think of this, because this is what you do also in elementary school. So when I did 4 plus 7, I put 7 up, right? We put 7 up here, we counted them down to get rid of them. So Katie said, why can't I just count them up? And you can do that too. So we're starting with 4, okay, and I'm going to stop when I get to 7 on my hands, okay? So if I take 4, and then I go 5, 6, 7, I don't have an 8. I have 1, 0, 1, 1, 1, 2, and 1, 3. So if that helps you a little bit different perspective of counting up till I got to 7. I stopped when I got 7 though, right? And it was 1, 3. I still wrote my 3 down. I carried my 1, and then I added the 3 plus the 1 and the 1 on top of the 5. We're going to do another one, and this one's subtraction. It's almost the same number, 34 minus 17. We're going to subtract. So we have this idea when you use subtraction, our standard algorithm anyway, that if the number on top is not large enough, we can borrow, right? And in base 10, when we borrowed 10 from the place to the right hand of it, correct? To the right, to the left of it, right directions, to the left. But why do we borrow 10? Because it's base 10. So now we're in base 8. So when we borrow in base 8, how many should we be borrowing? 8. Okay, so when I come over here and I borrow from my 3, 3 becomes a 2 just like before, but I'm borrowing 8 because I'm in base 8. So what is 8 plus 4? That's 12, just plain old 12, right? And then I can subtract after I've borrowed the correct number, I can subtract. So the 12 minus 7 is 5. And 2 minus 1 is 1. And just like last time, we would write 8 down there beside it, for base 8. I want to show you another thought for this. We had another subtraction method that was a little bit non-conventional. It was called equal additions algorithm. Remember, we added a value to both values, and we subtracted because it was a little easier. And in doing so, we avoided having to do any borrowing. So if you take a look at 1, 7, 1, 7, if I add the number 1 to it, what does it become? How about 2, 0? All right. 7's as high as I can go. Just like in our system, 9's as high as I can go. So if I had 19 in our base system and we added 1 to it, we'd get 20, because I have to increase the digit to the left by 1, and I turn the digit I'm working with into 0. Are you following? Okay, that's what we do. But of course, if I add it to the bottom, I have to add it to the top. So what's 34 plus 1? 35. And then when I subtract, there isn't any borrowing. What's 35 minus 20? That would be 15. And again, it's 1, 5, and then it's base 8. Okay? Subtraction of this. Okay, but I don't want you to get comfortable with base 8. That's kind of the problem with base 10. You're very comfortable with it. And so again, we're trying to put ourselves in the position of our students to think, what problems might they have? Why are they not changing, 19 into 20? Why are they changing 19 into 200 and 100? Because that was one of the suggestions when I told you to increase the value, right? So let's take a look, and we'll do base 3. All right, so in base 3, what are my digits in base 3? 0, 1, and 2. And we're going to add in base 3, I've got the number 1, 2, 1, 2, and I'm going to add the number 1, 1, 2. And the first thing we're going to do is our standard algorithm, the one you grew up learning and loving, or maybe not, okay, the one you know. All right, so if I add 2 plus 2, in our number system, that becomes the number 4. I don't have 4 in this base system, right? So we have to think about it in the same way. And if it helps you, you can write out a few of these digits. I didn't do it on the last one, but we can certainly do it pretty well here. What's after 2? 1, 0, and then 1, 1, and then 1, 2, and then 2, 0, and we can keep going, right? So if you see them written out a few steps, that might help. And we do this with kids too when they're working with base 10, right? And they do things like they draw lines and they show their addition, right? So if we started like this and we look at the number 2, since we do 2 plus 2, I start with 2 and I draw 2 lines over. And if I think about it from this number line perspective, and that's what this is, it's a number line. What is 2 plus 2 in base 3? It's 1, 1. Okay? So what do I do with 1, 1? Well, I write the number 1 down, and I carry the number 1 over here. Okay? All right, so let's do our hands now, because it's always good. So I've got the number 1, and yeah, we've got hands in here because we only have 3 fingers now, or something. I don't know if we have 2 fingers. Okay, so we have the number 1, and we add 1 to it, which gives us that 2, and that's perfectly fine. But then I can't have a number 3. So what comes after 2? 1, 0. I'm down to nothing. I don't have anything else. So I've got 1, 0. And if you do it from this over here, you can start out with 1, and you can move to the 2. And then you move it again to the 1, 0, and you stop. So, okay, where'd my marker go? Over here. So here's 0, and here's a carrying of a 1. Okay? Our hands don't work quite as well because we have too many fingers for these 3. All right, cut off some fingers. How about 1 plus 2? What's 1 plus 2 in base 3? 1, 0. And if I add 1 more, I get 1, 1. So I'm going to write the 1 down here and carry another 1. And 1 plus 1 is 2. And this is base 3. Okay. I wanted to do an example so you can see that lattice. Do you remember doing the lattice one last time? So it looked like, where do I have it? Here. This was the lattice one. We're going to do the lattice, the same problem. Okay, same problem. We're just going to do it with lattice so you can see how that would look. Okay, I think I moved something accidentally. All right. That's not where I am. One more. There we go. Okay, so let's do lattice. So I'm going to have 1, 2, 1, 2, 1, 1, 2, and I'm going to draw this sort of grid-looking shape underneath. I need a box underneath each one of these, and I'll divide my box diagonally. Okay? So there's no carrying right now. All I'm doing is the individual lines of addition. So we established just a little bit ago that 2 plus 2 is 1, 1. So we put a 1 on top and a 1 on bottom underneath that column, the 1's column. And then 1 plus 1 is actually 2. So I can put a 2 here on the bottom corner, and I can put a 0 here. If you want the 0, you can put the 0 off either way. And then I have 2 plus 1. That is 1, 0. And then I just have a single 1 down here. Okay, so what I do next is I look at these sort of diagonal grid markers and I add. So the first down near the bottom right hand corner, that's just 1. But now I have 1 plus 2, which is 0, 1, 0. So I've got a 0 and then I carry my 1. And then I have 1 plus 0, which is 1. And then I have 1 plus 1, which is 2. Did we get the same answer? Oh, that's good. This is base 3. That's great. It's always encouraging when you get what you expect to get. Okay. All right, and I think we have one more. Same idea, but it's subtraction. All right, so again, let's do our standard algorithm first. And a problem like this, even with our standard algorithm, is really tricky. And the reason it, like with their base 10 and everything, the reason it is because I'm going to have to borrow more than once because I got lots of zeros on top, more than one, right? So 2 minus 0 in the far right-hand corner, that's fine. That's 1. There's 2. No problem there. But the problem is, of course, I can't take 1 away from 0, and I can't borrow from the 0 next to it because there's nothing there either. Okay? So this is base 3. So when I borrow in base 3, how many am I borrowing? 3. So this 1 right here gets to be borrowed from to become a 0, and this 0 becomes a 3. But I need to borrow from that 3 to get this 0 to become something else as well. So the 3 is actually going to become a 2, and this 0 is going to become a 3. Okay? So then 3 minus 1, that's 2. 2 minus 1 is 1. This is 1, 2, 2, base 3. And we're going to practice our hands one more time at doing the equal additions algorithm. I want it down here because I want to be able to move across my page. So you might want to work over on the lines on the side or down at the very bottom where there's more space. Because I'm going to have to add several times. All right, so the first issue is that 1, 1, 0 is not so bad. Right? I've got a 0 there, that's good. I've got one of them being a 0 already. But I want both the numbers in the first place and the second place to both be zeros. What would I need to add to this to turn this into something and then 0, 0? I want this to become some number here, but then these both here to be zeros. I don't have 9s. If I add a 1, it'll just turn into 2. Or, I'm okay with the top not having zeros. That's no problem. Well, 4. There aren't any 4s in base 3. But it'd be 20. 2, 0. 2, 0. How about that? That's right. I'm in. Okay. So, right, I really want the number here in the middle here to become, in my mind, 3. This is base 3, right? Because if in my mind it becomes a 3, I know I have to carry over the next digit. Because I've got too many. I don't have 3s in base 3. So let's look at this particular part right here first. So this 0 and this 0, those are 0. This 2 and this 1 become 1, 0. This is 0, and there's a 1, and I've got 1 plus this 1 is 2. Okay? But if I added 2 zeros to the bottom number, I have to add 2 zeros to the top number. But I can do that because that one's really clean, isn't it? So what do I have? Well, I've got 1, 0, 2, 0. But I got a problem.
You did 2, 0.
I left my 2 off, didn't I? I'm sorry. Well, once I fix that, I still have a problem. What's my problem? What about it?
You have to borrow.
That third column would still need borrowing to work, right? And the whole point in equal additions is that I'm not going to be borrowing. So is there a value that I could add to the third column to make the value on the bottom a 0 in the third column? 100 would work. 1, 0, 0. Yeah. Okay, so Marissa told me that this is 1, 0, 0. So what is 2, 0, 0 plus 1, 0, 0? Well, I got 2 zeros. And then what do I have?
0, 1.
Yeah. 2 plus 1 is, well, it normally is 3 in base 10. It's 1, 0 in base 3. Okay? And then how about this 1, 0, 2, 2 plus 100? Plus 1, 0, 0. 1, 1, 2, 2, and then I can subtract, right? And then all my subtraction is flat out straight down. I don't have to do any borrowing. Okay? So let's come down and do this. 2 minus 0 is, 2 minus 0 is, 1 minus 0 is, 1 minus 1 is, and of course this is base 3 on the end of it. And it's the same solution possible, right? Yes, yeah.
And the top problem, why did you do it?
Because I'm not, well, it's kind of like when we do this. You do this with your, in base 10, you just don't think about it that way. When you borrow from a column over here, you borrow 10 of them.
Yeah.
So you write the number above here like 14. You can't have a 14 in a single spot in our number system, right? Same thing here. You can't have a 3 in a single spot here, but because you're borrowing, you're counting differently. Okay, it just doesn't have the form of having 2 digits next to it like ours in base 10 does. Yeah. All right, we're going to stop here on this one.